My project was called Exploring Indexing Methods for Handwritten Text. And so this project focuses on methods of indexing that currently exist for documents with handwritten text. Specifically, I tested a handwritten text recognition tool on an acquisition logbook that you can see right here, which documented items acquired by the Calvert Marine Museum in 2002. The logbook contains approximately 300 pages and is filled out in a spreadsheet style across every 2 pages. In order to update the archives and allow for digital queries of these acquired items, the Marine Museum asked volunteers to manually transcribe the logbook contents into an Excel spreadsheet. And after volunteers spent multiple shifts working on this task, we estimated the transcription process rate to be approximately 2 of these open face pages per 2-hour volunteer shift. So basically 1 of what you're seeing per every 2 hours. Could also be different, depending on the volunteer. But due to this extremely slow process, we really wanted to find an alternate method for digitizing all of this. As a student in this class and as a volunteer there, I saw an opportunity to explore a better solution. And so I looked for a tool to do this. So optical character recognition, I won't get into. I'm going to assume everyone here kind of knows what it is. But handwritten text recognition is kind of the next step, or a little bit more advanced than OCR. And by nature, it's just a lot more difficult to digitize handwritten text due to the uniqueness of individual penmanship. So every person has a slightly different writing style that can also differ with that same person if they're writing quickly or slowly, if they've been writing for a while, their hand is getting fatigued. I know my handwriting's pretty awful if I've been writing for a long time. So given all these variables, it can be a lot more challenging to train the OCR software to read that individualized text. The majority of OCR tools and scanners with built-in OCR are not really designed for handwritten text because of that. So most OCR focuses on actual typed text that's more uniform than handwritten. Right now, if you try to scan handwritten text, a lot of these tools will handle it as an image, the handwritten part, instead of as text to try to transcribe. So accuracy, OCR itself for typed text is pretty accurate at this point. There's a lot of different tools that you can use. One website said that it's about 99% accurate, give or take, depending on the tool. To measure accuracy, there's 2 different measures. There's word error rate and there's character error rate. And to measure these errors, there's 3 different errors that are kind of tallied up. There's substitution, which is misspelled characters or words. There's deletion, lost or misspelled or missing. And there's insertion, which is incorrect inclusion. And here's an image that I really like that shows those 3 error types. And there's a measurement that's called, I don't know how to say it right, Levenshtein distance. And it is the distance metric that's measuring the difference between 2 string sequences. So the correct transcription and the one that's been automatically done with the software. And it is the minimum number of single character or word edits, these 3 edit or error types, required to change one word or sentence into another. CER and WER are calculated using that concept, where S, D, and I represent the edits needed to match the transcription to the ground truth text. And then the difference between the two is that CER is used to calculate individual character error rate, and WER focuses on the entire words. This is just a snapshot that I found really interesting, that's showing accuracy and what's considered good for OCR at this point, actually as of 2009. You can see, at least back then, they considered 20% accurate fairly good. It's definitely changed a little bit, but it's still not great for handwritten text. Before choosing what tool I was going to use for my project, I did some research on what's available in the market right now. And there's definitely a large selection to choose from. This is not all products available. I did have a few limiting factors that affected my choice. I didn't really have money I was willing to spend on an expensive software. There are definitely some very nice ones out there that promise some good things. There's also the 12-week limit for the project for this course. So I prioritize products that did a free trial or were completely free. Ultimately, I decided to go with Transcribus. They do allow for 500 free credits, which according to the website is approximately 500 pages of handwritten text. Transcribus stood out to me because of its open source model. And it was also used by the National Archives in 2018 for one of their projects. This platform was developed by the READ project and funded by the European Union. READ Co-op SCA currently has 135 member organizations from 30 different countries who contribute to and use this platform and the AI models. So it definitely has a large base that is using it, which is really cool to see. It's also designed so that users can create and upload their own HTR models for others to use, which is really nice. If anyone's looking for a specific kind of handwriting or a specific language, they might have one there that's already been at least partially trained that someone can use without having to go through the whole training process from scratch. Some of these examples are Balinese palm leaf manuscripts from the 16th century and Dutch poetry from 1603 to 1636. So steps for doing OCR, for digitizing these kinds of texts and documents, is first to upload the images of your document. Then you pre-process the images to make sure that the contrast is good and the software can pick it up, make sure your images are straight, things like that. Then you get into the segmentation where you're defining where on this page is the actual text that I want to scan and transcribe, and other like layout modifications. And then you will set where you want the lines, the baselines of the actual transcription, and then the reading order of it. So that matters a lot. And you don't want it to go backwards or something. You want it to read in the correct order. And sometimes with some of these documents, it's not that obvious. And then on the right, there is a sample of an initial test that I did on the Transcribus website. They have a little like, put your image in here and see how it transcribes. As you can see from the text on the far right, didn't do a great job. A lot of those words don't look like real words. So this is without any kind of training. I could see right off the bat, there were going to be some issues and it would require a lot of training to get familiar with this person's handwriting. This is a little bit more of me copying that text, the output text, and then I put in my own manual transcription. You can see that it also didn't break apart each cell very well. So on the left, that should actually be two separate cells or two separate lines, and it got merged together. Some text it did all right with. And then again, some of the words like photos just didn't go through very well. So then I got into the actual platform to test out and see how far I could get with Transcribus and my document. So in order to pull text from the page, the software needs to know which areas to target and in what order. So again, that's the text regions and line orders. Transcribus has an auto segmentation and line recognition tool that searches for those text regions and numbers the lines and sections in order. And I included links throughout this project presentation if anyone ever wants to try it. There's steps for it that they have done. That first image is sort of the process of how you get that started to do the automatic segmentation. And I just have laid out kind of where you click to do each of those. The third image there shows how it's broken down. And you can see it produced some interesting results where it wanted to go down each column first before going to the right, when I really needed it to go across each row, you know, cell by cell, and then go down to the next line. So I quickly decided that this first method with the auto segmentation was not going to work very well for me. And I tried switching to a different one. Here you can see it a little bit better. It broke things apart nicely, but the way that it ultimately wanted to read things just didn't work for me. Then I tried a second method where I manually highlighted the text regions and created a table instead of using the auto segmentation. So I just told it, hey, here's where I want these cells to be, to see if that would help with the order a little bit. And you can just see in these images where I clicked to do that. The other thing about this is with creating the table, you can also create a template to use on other pages. So if you can get your photos all lined up nicely enough, and this method works for you, the hope is that then you could apply it to all your other pages and not have to recreate the table each time. And these are more steps of how I created that table, creating borders. And that third image on the right is how you would copy the template over to another page. And then after you have created the table, you go back and you run out the layout analysis again. Important thing is to unselect the find text regions because you've already done that. And then you run it and it'll search for the lines and bylines and create that reading order. This method worked a lot better. So the reading order was correct this time. It did require a bit of touch up, as you can see in the far right side. Some of the numbering was a little bit weird and I had to go in and say, like, break some of these cells apart, even though I had created the table. So it was not perfect, but it was better. And there, yeah, so the layout was more accurate. But the line numbering was a little bit difficult to navigate. It wanted everything to be a 1, which I thought would cause problems when I export it if I'm trying to find a specific line. I'm not sure what I would tell the code to look for. So then I tried 1/3 method just to see if I could get it to work any better. Ultimately, this third method did not prove to be any more effective. I tried manually creating the columns. I did this just on a smaller section. And basically what I learned, if I don't use the table method, then when I try to export it, it won't know that these are cells that need to be put into an Excel spreadsheet. So it would just want to switch it over as more of a document layout. So the third method was not what I went with. Ultimately, I decided that method 2 was the most effective segmentation method, and it did allow for fairly simple layout analysis and transcription. However, due to the cells all being numbered 1, I was a bit worried about how it would export. The ideal layout and reading order would have each cell labeled by row and column number and would read from left to right, and the numbers would get progressively higher. This could potentially be achieved in Transcribus if the user manually created a table as done in method 2, and then manually relabeled every cell on the page, which I decided was not worth the time that it would take, and it probably wouldn't be any faster than just manually transcribing at that point. I was unable to export the table after I did this because I ran into an error with the actual platform itself. The button to export the entire table to Excel was not available. And so my project sort of stopped there as far as getting the actual data out. And you can see the image there in that red box. There's a section missing. What I think happened here is that they have since posted that they're going to be switching to their browser version, the light version, and they are no longer working on the client version of this platform. And I think that that feature is just no longer supported. So next steps for me are going to be retrying this in Transcribus Lite in the web-based version and see if that feature is available, which it should be. And hopefully I'll be able to actually get more transcribed and pull it over into an Excel and have some real results. The next thing would be training the pattern recognition model. So I did some sample pages, but I would need to do about 25 pages of text in order to train this HTR model onto this specific handwriting to have any kind of accurate results, which I do really want to do. So if I can figure out the export issue, then I'm going to go ahead and see if I can train the model. After that, I would work with the data in Excel. So once I export it, I would still have the issue of every other page needing to kind of go over into the right side of the Excel spreadsheet, since each page is not its own thing. You know, every 2 pages need to go together. So I would have to figure out how to export that or manipulate it after it had been exported. And then after that, I am going to explore a few of the other tools that had good reviews, see how far I can get without having to pay for an account, or see if I can just do a couple trials or reach out and ask if they'll let me do anything as a student. Definitely excited to see what the other tools look like and how they feel to work with. And as far as the future of handwritten text recognition, I think that it's going to keep growing. It's pretty exciting. There's a lot of stories about it in the news right now. OCR has been growing for a while. It's been around for years and years, and it's just gotten more and more effective. And according to nanonets.com, the OCR market is expected to grow pretty significantly. There are some updates from Transcribus. They sent out an email to all users saying that they're working on some updates that are going to focus on field and table models, which is pretty exciting. I think other people probably had the same issue as me, which kind of validated made me feel like I wasn't going crazy. So I'm pretty excited to see what those will look like and if those will make it easier to do what I'm trying to do. And as far as HTR in the news, the National Archives did a pilot program with Transcribus specifically in 2018, where they worked on a collection of wills. And Professor Marciano actually told me about this one, and also told me about Ancestry.com doing a project where they released the 1940s census. I believe it was the 40s. They indexed it, so it's actually searchable. And the thing that was significant about that is that they at least partially used HTR software that they have not released to other people, but they partially used software that would transcribe that for them. I think some of it was still manually transcribed, but it gives hope for the future that this is something that's coming and people are going to start getting interested in it. And then I also found Geneza Lab at Princeton University worked on transcribing Geneza documents, which was interesting because it's in a totally different language. and they called it Digital Paleography Framework, which was a different term than what I'd heard before. And yeah, these are all of my resources. There's a lot of talk about it, which is really exciting. And we'll see what happens in the future.